Up till now, we've been looking at data in the form of variables. And that is if we have something called age, something that we have called price, and we have single values. But the reality is most programming languages, if not all of them, have some more complex data structures that are commonly used to make processing data easier. One of the most common ones is called a list. And we're going to be using lists quite a bit between now and the rest of the semester. And I just want to take a minute to introduce lists to you and show you a variety of ways they can be used. So let's take a look at this first example. On line 2 here, I've created an empty list. And you'll notice the use of the 2 brackets. You commonly will use empty lists when you want to build a list of something. So you have something you're asking the user to enter information. You can start with an empty list, and this is actually how you create an empty list. Line 3, you'll see a list of strings in the form of my family. And again, strings can be any data type. As a matter of fact, a list can be any data type. And as a matter of fact, a list can even contain different variable types. Even though the examples I present here are all uniform in terms of their data types, you can actually mix data types within a list. It's not commonly done. We won't do that much in this class, but you will see that occasionally. Line 4, you'll see some floats and different numeric values that will indicate an item's cost. If I run this program, all I'm doing here is printing the values, but it gives you an idea of what they look like. And again, the program just prints out and lists the values, as you can see. Well, what else can we do with a list? Well, you commonly are going to want to extract a value from the list, and we can do that using an index. Here you'll see, for example, wages. Let me change this value from wages to item cost. Each item in the list is indexed. The first item always is the index of 0, which again is counterintuitive. It seems like it should be a number 1, but remember, computers do not count the same way human beings do. Humans always count with number 1, 2, 3, but computers, generally speaking, start with the number 0. The first item in any list is going to be the 0th element. The first item in my family, for example, is Mark, so therefore my family sub 0 will actually be Mark. If I go ahead and run this again, you can see the result, and you'll see that the result is 35.55, which is, like I said, the first item in the list. Again, understand that if you look at the number of items in the list, there are 4 items here, for example. There is no 4th item in this list. If I try to print, for example, the item cost sub 4, this will generate an error. And the reason is because there is no 4th element. The index is out of range. There is a 0th element, 1st element, 2nd element, and 3rd element, but there is no 4th element. The reason is, of course, because computers start with the number 0. An extremely important concept is the idea of iterating a list. Iteration means you're going step by step through the elements in the list, visiting each element in turn. Incredibly powerful concept here, because we're going to be doing this a lot. Python enables you to iterate a list 2 different ways. Probably the easiest way to do it is without any kind of an index. And you'll see that on lines 7 and 8. If I want to step through the people in my family, the persons in my family, I can use this format in Python. If I run it, you'll see what happens. It simply prints the names of the people in the list. But again, the concept here is what's most important. It goes through the list step by step and visits. Person, in effect, becomes Mark the first time through and then runs and prints. The second time through it becomes Lorraine. Third time through it becomes Ryan. Fourth time through it becomes Katie. Extremely important concept. And Python makes that very, very easy. And in some ways, it wants you to use this approach. Another way to iterate a list is to use the range function. On line 11, you'll see, for example, that I have a range function starting with 0, and then it goes to the length of my family. Now, there are 4 elements in my family, as I showed you earlier. So 0, 4 will iterate the numbers 0, 1, 2, and 3. But remember, it will never get to 4. The reason, as we've talked about in class, is that the first number in the range function, the first number is always inclusive, the second number is always exclusive. That means it will never get to 4. Line 12 will execute and it will print the first time through my family sub 0, which is Mark. The second time through it will print my family sub 1, which is my wife Lorraine. The third time through it will print my family sub 2, which is my son Ryan. And then the last time through it will print my family sub 3, which is my daughter Katie. Again, remember, it will never get to 4. By the way, you will commonly see this approach instead because the number 0 is understood. If it's not there, Python will always start with 0 because, again, computers generally start with 0. So this will also do exactly the same thing. If I run this, you'll see, again, it prints out the names in my family one by one. We've talked about accumulators in an earlier module, and here what we can do is we can take a list of numbers, and that is the item cost, and we can in effect total up the bill to find out what the total expense is. The way to do this is very similar, but what we're going to do is we're going to iterate through the list so that we visit each of the item costs in turn. We're then going to use total, which has been set to 0, and as we go through, each element of the list will be added to total, and in the end we'll have a total amount. So if I go ahead and run this, you'll see that the total cost is $196.20. And if you add this up, you'll see that those 4 numbers add up to that total. This is an extremely powerful pattern. It can be modified in a lot of different ways. So I would strongly encourage you to spend a little time practicing this because this, again, very useful application of lists.